Hey, welcome to our explainer. Every single thing you do online, liking a photo, booking a flight, you name it, it's all powered by this invisible force. Today, we're going to flip on the lights and reveal that force, databases. These are the true, hidden engines of the internet.
Have you ever stopped to wonder how your favorite app remembers you every time you log in? Or how Netflix just knows what you want to watch next? How does the whole internet seem to have this perfect memory of who you are, what you've done, and what you like?
Well, the answer isn't some kind of digital magic. It's actually just organization. All of that memory, all that personal detail is stored in a powerful, structured collection of data. It's not just about having the information, it's all about how you manage it.
Okay, so let's get right to it and put a name on this thing. What exactly is a database?
At its absolute core, a database is really just a collection of data. That could be something as simple as the contact list on your phone. Or it could be the mind-bogglingly huge system that Facebook uses to store billions of photos and connections. Both of them are databases. The only real difference is the incredible scale. But, a collection of data is just like a warehouse full of boxes. It doesn't actually do anything on its own. To make it useful, you need a manager, a piece of software that acts as the brain, the gatekeeper, and the operator, all rolled into one. That manager has a name, a DBMS, which stands for Database Management System. You might also see it written as SGBD in other languages. This is the software that does all the heavy lifting, controlling who gets in, finding the right piece of data, and presenting it in a way that's actually useful. It really is the brain of the whole operation.
And this is a really important distinction to make. The DBMS is the software that manages the data. The database is the data itself. The best analogy is a librarian versus the library. They're two totally different things, but they absolutely have to work together.
So if the DBMS is our librarian, how should the books in the library be organized? What's the system? Well, it turns out there isn't just one way. Over the decades, we've come up with 4 major models, and each one was designed to solve the problems of the one that came before it. Let's do a super quick trip back in time. Things kicked off in the 60s with these really rigid, tree-like structures. Then the 70s hit and bam! A full-on revolution happens with something called the relational model. That got its own universal language, SQL, in the 80s, which basically set the stage for everything that came later, with the web and the cloud.
Let's start with that very first model from the 60s, the hierarchical model. Honestly, the best way to picture this is like a family tree, or maybe a company's org chart. Everything flows from the top down.
The logic here is super strict. Every child file can only have one parent folder. That's it. This one-to-many relationship is simple, it's secure, and it's efficient. If you've ever dug around in the folders of the Windows registry, you've seen this exact model. But that single-parent rule, that turned out to be a pretty big limitation.
What if one file needs to be in 2 different folders at the same time? That's exactly the problem the network model was designed to solve. It just threw out that single-parent rule, allowing records to have multiple parents, creating this really complex, interconnected web of data.
This gave it incredible flexibility for mapping messy, real-world relationships. But the downside? Oh, it was a big one. That flexibility was an absolute nightmare to manage. Building these things was so hard that it created this huge demand for something much simpler.
And that need for simplicity? Well, it paved the way for a true revolution. A new model that was so simple, so intuitive, that it would go on to basically dominate the entire digital world. This is the relational model.
The genius of the relational model is just how simple it is. It organizes all the data into tables, just like a spreadsheet, that we can all understand. This example is in Portuguese, so you see nome for name and DTNASC for date of birth. Each row is a unique record, a person, and each column is just a piece of info about them. It's instantly understandable.
But the real magic here isn't even the table. It's the language you use to talk to it, SQL. And the core idea is just brilliant. You tell the database what you want, not how to go and get it. You just say, find all customers from Brazil. And the DBMS handles all the complicated stuff, figuring out the most efficient path to that information. This simplicity made everything easier to design and manage. Now, the trade-off is that it needs some serious hardware, and a bad design can cause major headaches. But still, the benefits were so huge that this model, used by systems like MySQL and Oracle,
still powers a massive portion of the modern web.
Okay, but what about things that don't fit so neatly into tables? The real world is messy, right? So this next model tries to replicate that real-world complexity by bundling data and its actions together into these single structures we call objects.
So think of a car object. It holds data, like its color and its current speed, but it also holds the things it can do, its methods, like accelerate and brake. A class is just the blueprint for making more similar cars. An inheritance is this cool trick where you can have a sports car class that gets all the basics from the car blueprint, but then adds its own new thing, like an activate turbo method. It's a really powerful way to model complex systems.
So, we've seen all these different ways to organize data, but let's zoom back out to the big question. Why does any of this actually matter? What's the real-world impact?
350 million. That is an enormous number. And that's about how many photos are uploaded to Facebook. Not in a year, not in a month, every single day. Each photo stored, linked to your user, ready to be seen instantly. That incredible feat is only possible because of databases.
But it's about so much more than just storage. Databases are what allow companies to spot trends, manage millions of customers, and make absolutely critical business decisions. They are designed specifically to transform raw, messy information into actionable intelligence.
Because at the end of the day, the value isn't in the information itself. It's in the actions that you take because of that information. Knowing that your customers are unhappy is kind of useless unless you actually do something about it. Databases are the engine that finds that insight and drives that action.
So from our simple phone contact lists to these massive global social networks, our entire digital world is built on these powerful logical structures. And as AI and the Internet of Things create even more unimaginable amounts of data, these models are going to have to evolve yet again. Which leaves us with one final, fascinating question. Who's going to decide how the databases of our digital future will evolve?